Hello everyone. Today we'll be talking about size separation. Size separation is a unit operation which goes hand in hand with size reduction. Let's have a brief overview about size separation and some of the major equipments which are utilized in size separation technique. Now, size separation basically means separation of a mixture of particles into two or more fractions by means of a separator or by means of a screening surface. So basically when you are having a mixture of different size of particles, and if it is intended that you want to separate them into various fractions, the technique that you are going to use is size separation. So after size reduction is actually done, when the size of a given batch is reduced, it is desirable that you separate that batch into various fragments. Now, how do we decide that what should be the size of a given batch? The answer to that is it is given in Indian Pharmacopoeia, which clearly mentions what should be the size of a given powder or a given granule depending on how coarse it is or how fine it is. Coarse means a larger granule and fine is more or less a dust. We will be discussing more about this, that is size of particles and size of sieves, which are actually utilized for size separation technique in our later lectures. Now basically there are four techniques for size separation. I have increased the font of the first technique, that is sieving, because we are going to discuss about this today. It is one of the easiest technique, yet it is important. I think you remember this technique. We have performed practical on this technique in a sieve separator in our lab. The other three techniques are cyclone separator, air separator and elutriation. Elutriation is again very important technique as far as GTU examination is concerned. Now, if we talk about sieving in brief, now what is sieving? Sieving is separation of fine powders from their coarser or larger versions by using sieves. Now, the degree of fineness of a powder is known by the sieve through which the material is going to pass. So you can actually judge કે કયા ટાઈપનો પાવડર છે, કયા ટાઈપના ગ્રેન્યુલ્સ છે, એ ડિપેન્ડ કરે છે કે કયા નંબરની સીવ પર રિટેન થાય છે. સીવનું નંબરિંગ એટલા માટે કરવામાં આવે છે સો દેટ યુ કેન ડિસ્ટિંગ્વિશ, યુ કેન આઈડેન્ટિફાઈ કે ઓકે this is this numbered sieve, this is this numbered sieve. આની અંદર આટલા સાઇઝના પાર્ટિકલ થઈ શકશે, આની અંદર આનાથી મોટા પાર્ટિકલ જઈ શકશે. સો યુઝ્યુઅલી sieves are numbered. Now separation of powder will be done by a set of sieves. Again, if you remember the practical, there were 8 sieves in a sieve set usually, and the sieves are arranged in a descending order. સૌથી ઉપરની તરફ જે સીવ મુકાય એનો મેશ સાઇઝ, કે એની અંદરના જે વાયર્સ હોય, કે એની અંદર જે સ્ક્વેર બને એ સ્ક્વેર સૌથી મોટું હોય. સો દેટ ઇઝ યોર લાર્જેસ્ટ સીવ, and the sieve which is placed at the bottom, that will be the least sized, and the entire arrangement is attached to a pan, which is your mechanical device with which the size separation will take place. So basically you will have a sieve set. Sieve set will have 8 or more sieves. Sieves are numbered so that you can identify them. Sieves are placed according to their size. This is the simplest diagram of how a sieve set will look like. As you can see, there is a bunch of sieves. It is connected to a mechanical device which is going to operate or which is going to perform the sieving operation. The same arrangement is there in our lab as well. You need to draw this diagram when you are writing this answer. You know me. Oscillation, vibration and gyration. The Second technique is brushing. So what we will have a sieve set, and on each of the sieve we will have a brush. Now what is brush going to do? If at all the granules or the powder material is clogged inside a sieve, it is going to be brushed or moved by a small smooth brush. Okay, so that is going to make the meshes clear, and they are usually rotated in the middle of the sieve. Imagine આપણો sieve set છે ને એની વચ્ચે આપણે વચ્ચે વચ્ચે બ્રશ ફેરવતા રહીએ તો શું થાય કે ક્યાંય ક્લોગિંગ ના થાય. બસ ધ્યાન એ રાખવાનું કે એ બ્રશથી ફોર્સ્ડ સેપરેશન ના થવું જોઈએ, કોઈ પાર્ટિકલનો ધક્કો લાગીને નીચે ના આવવા જોઈએ, પોતાની રીતે જ સેપરેટ થવા જોઈએ. Now the third technique is centrifugal methods, as I talked about it in the previous slide. Remember gyration. So centrifugal methods is સીવ્સની બંને તરફ there will be rods. આપણા જે સીવ સેટ છે લેબમાં એની અંદર આ જ છે, અને એ જે રોડ્સ છે એની મદદથી આખા સીવ સેટને સર્ક્યુલર મોશનમાં ફેરવે રાખે with the help of a rotor. Now this continues till the size separation takes place. There is an additional benefit. There will be generation of currents of air which facilitates the sieve separation process. So what needs to be done after sieving? You already know. You need to weigh the amount of material retained on each sieve, calculate the percentage of that, and perform particle size analysis. You need to calculate that on which particular sieve number maximum amount of powder is retained, and you can conclude that out of the entire batch maximum particles are of dash size. So in general, sieving method is a rapid process. It is very fast and it doesn't require any technical expertise, and the equipment of sieving is least expensive out of all the 4 techniques that I showed you in the front slides. That's all for today's session. We'll be talking more about this in our later classes. Thank you for listening.